Hello and welcome back to Dr. Logic awkwardly does logic in her office. Today I'm going to talk to you about the square of oppositions. Now, in our previous video, I defined 4 different types of relationships that pairs of categorical propositions can have to each other. They can be contradictories, they can be contraries, they can be subcontraries, or they can be in the subaltern superaltern relation. Now, not every pair of propositions is going to stand in one of these relations to each other. There are many propositions that are basically entirely unrelated. But what we showed at the end of the previous video was that if you fix the categorical terms x and y, then the same proposition with either the E copula or the I copula, that pair are going to stand in the contradictory relation. So let me bring up my handy dandy whiteboard so that that's not well, there we go. So that you've got the definitions up there in case you need a brief refresher. So what we showed was, just an extra bit there, that if I have, say, x e y and x I y, that this pair of propositions are contradictories. Running out of room. There we go. Now, you can prove in the same way that we proved in the previous video a number of other relationships between pairs of categorical propositions. So again, we're going to fix our terms, we're going to keep the same x and y and just vary the copulae between them. Now, these other things that I'm going to write down, I'm not going to prove them in the way that I proved that I and the E claims are contradictory to each other. You can prove this for yourself, and I strongly encourage you to, because it's good practice to make sure that you have a really clear understanding of how interpretations work, what these definitions mean. So what I'm doing now is simply reporting without proof certain facts about relationships between pairs of propositions. First of all, we need to say something about A claims and something about O claims. It shouldn't surprise you that these are going to be contra. It's really awkward writing diagonally. They are also going to be contradictories. If you go back to the definition of their truth condition, you'll see that they differ from each other in exactly the same way that the I and the E claims do, just by one saying the subset relationship holds and the other saying the subset relation doesn't hold. So that shouldn't be surprising. What's fascinating is that we have the relationship of contrary between the universal affirmative and the universal negative. So, for instance, all cats are mammals and no cats are mammals cannot both be true at the same time. Let's actually pick a better example. All cats are black, no cats are black. Can't both be true at the same time. On the other hand, it's possible that they could both be false, because maybe we have contraries down here. Maybe we have that some cats are black and some cats are not black. This is entirely in keeping with what we know about cats and color. So the universal affirmative and the universal negative cannot both be true at the same time, but they could both be false. And this is why the partial affirmative and the partial negative, the I and the O claims, are subcontraries. It's perfectly possible for them to be true on the same interpretation, but they cannot both be false. So it cannot be false that some cat is black, while at the very same time it is false that some cat is not black. This doesn't work because we are always assuming that there are cats. And this is an important notion. So remember back to the definitions of interpretations, we said that our interpretations have to be non-empty. So if I'm saying a statement about some cats, or all cats, or no cats, there has to be at least one cat. And that is why we have the subaltern. Oh my goodness, how am I going to do this? Sorry. Subaltern and subaltern relationship going from the A to the I. So I claims are subalternate to A claims, O are subalternate to E, and then we have I'm just going to write this one like this because I can, the relationship of the superaltern. The superaltern of an I claim is an A claim, and the superaltern of an O claim is an E claim. Look at this. It's a square, and it's talking about ways pairs of propositions can be opposed to each other, either in a contradictory relationship or a contrary or a subcontrary. We have the square of oppositions, as I promised you. Now, each of these relationships, as I said, and I'm going to stress this again because this is something that sometimes my students struggle with, is that you don't get these by definition. We do not define A and O claims as contradictories. They turn out to be contradictories given how we defined truth and how we defined contradictory. So that's what we define. The relationships that are in this square are then things that have to be proven. We don't get them for free. We don't define them by fiat. So this is why I would like to encourage you all to try to prove some of these things. So the fact that the I claim and the E claim are contradictory, we did that. So you can kind of highlight this one as being proved. All of the other ones are not yet proved, but provable. So I would like to encourage everybody to go back to the proof that I gave in the previous video and see if you can work out how you would prove the other kind of facts that I've represented in this square of oppositions. You know that they're true, and so that's the first step towards making a proof. But now, can you actually use the definitions to show why they are true? That's what I have to say about relationships between pairs of propositions. So we can stop sharing this for now. In the next video, I will talk about relationships between more than pairs of propositions. We will get back to actually talking about syllogisms and the notion of a good argument. I will finally be able to give you a definition of this notion in the syllogistic, given all of the machinery that we've developed so far. So I look forward to seeing you then. Cheers.